let's talk about the Shoelace Theorem. The Shoelace Theorem is just a way to find the area of a polygon given its vertices on the coordinate plane. So basically, if you have the coordinate plane and you're given the vertices a, of a rectangle or a square or a triangle, then you can find the area using the shoelace method. Now, the one that you're probably going to encounter the most is the triangle. So let's look at that. So let's say we have this problem. We're trying to find the area of a triangle given the vertices negative 2, 2, 2, 5, and 2, negative 1. First, we have to set it up. We're going to do negative 2, 2. Then we're going to write 2, 5. Then we're going to write 2, negative 1. And then we're going to write negative 2, 2 one more time. Now what we're going to do is we're going to multiply all of these pairs. So negative 2 times 5, that's negative 10. 2 times negative 1, that's negative 2. And 2 times 2, that's 4. So negative 10 minus 2, that's negative 12. Plus 4, that's negative 8. Now we're going to use the next set. Well, we're going to do it basically the other way. 2 times 2 is 4. 5 times 2 is 10. Right, negative 1 times negative 2, that's positive 2. And so 4 plus 10, that's 14, plus 2 is 16. Now we're going to take the first number that we got and subtract it with the second number. Take the absolute value of that and then multiply by 1/2. So negative 8 minus 16 is negative 24. And the absolute value of negative 24 is 24. And so we'll do 24 times 1/2, and that's equal to 12. And so that's our final answer. The area of a triangle with those vertices is 12. Okay, let's look at another example. Let's say we have this problem. We're trying to find the area of a triangle with vertices at negative 3, 4, negative 2, negative 3, and 5, 1. So we use the same process. Negative 3, 4, negative 2, negative 3, and 5, 1. And then we'll write the first number again, or the first set of vertices again. Now we're going to multiply each of these pairs. So negative 3 times negative 3, that's 9, minus 2, plus 20. This is 27. And then we're going to do the next other, basically flip it and they do the other side. 4 times negative 2 is negative 8. Negative 3 times 5 is negative 15. And then negative 3 times 1, that's negative 3. So this is negative 23 minus 3, that's negative 26. Now we're going to take the first number and subtract it with the second number. Then we're going to take the absolute value and multiply that by 1/2. 26 minus minus, that becomes a plus. So 27 plus 26, that's 53, times 1/2. That's going to be 26.5. And that's our final answer. Let's do one more practice problem. Let's say we have this problem. We're trying to find the area of a triangle with vertices at negative 2, 5, 6, 3, and 0, negative 4. Again, we set out the problem by writing out all the vertices and then writing the first vertex again. Negative 2, 5, 6, 3, 0, negative 4, and negative 2, 5 again. Then we're going to multiply each of these pairs. Negative 2 times negative 3 is negative 6. 6 times negative 4 is negative 24. And 0 times 5 is 0. So this is negative 30. Then we'll do it the other way. 6 times 5 is 30, plus 0, plus 8. This is 38. And then we're going to take the first number and subtract it with the second number. Then we're going to take the absolute value and multiply by 1/2. So this is negative 68, and we'll take the absolute value of that to get 68. Then we'll multiply by 1/2, and that's going to be 34. So our final answer is 34. Now, the Shoelace Theorem can be a little bit tricky, so this requires a lot of practice. I'll link the practice worksheet and its answers in the comment section, so make sure to go check those out.